All right, guys, 6.7, solving radical equations. Three key concepts. First of all, we want to isolate the radical by undoing numbers around it to the other side of the equals. Here's a shortcut, if the radical equals a negative number and the radical is even index, then you have a no solution. The answer you would have gotten is an extraneous solution, just to kind of give you a heads up on what no solutions would be. Number 2, raise each side of the equation to a power equal to the index to eliminate the radical. And the third step in solving radicals is to solve whatever equation is left. And then here's some examples. So in this example here, we want to go ahead and take the 10, undo it to the other side as a negative 10, and therefore we have the square root of 2x. That negative is understood to be like a negative 1, so we're going to go ahead and divide by negative 1. So we end up with the square root of 2x equals 5. To undo the square root, you're going to go ahead and square both sides, keeping it balanced. So the square and the square root cancel out. You end up with 2x equals 25. Therefore, x equals 25 over 12, or 12.5. And that would be a solution. You can always check it by plugging it back in and see if it does indeed equal 5. The next one we're going to go ahead and take a look at is the 8 and the radicals, x plus 1 equals 2. The 8 got to go to the other side. Negative 6. This one is, like I told you, if you have an even index right here, this is an even index, and notice you have a negative. That cannot happen. So right away you can just say no solution. You could keep solving if you wanted to, but the answer is not going to work. You cannot produce a negative number coming out of an even index. So therefore, you end up with a no solution. We can solve it. Just to let you know, you would square both sides, and x would equal 35. But once again, try plugging 35 in, and it will not equal to 2. So give you a heads up, no solution would be the answer. 35 would be called extraneous. Okay, next. These are the last two examples. On this one here, we want to go ahead. So we want to go ahead and solve for x, which is housed inside this radical piece. So we want to isolate that radical piece. And by doing so, we're going to go ahead and undo this 2 to the other side. And then we're going to divide by 4. So let's see what kind of equation that leads me here. We have the cube root of 2x plus 11 equals, we have the 12 divided by 4, so that would equal 3. So the cube root, oh, very sloppy. The cube root of 2x plus 11 is equal to 3. I need to undo this cube root, so you raise it to a third power, both sides, and that undoes it. So you're left with 2x plus 11 equals 3 times 3 times 3, 27. You're going to then minus the 11, whatever you get, divided by 2. So let's see here. So we backtrack there. When we minus the 11, you're going to get 16 divided by 2. So I end up with x equals 8. That will work since I had a cube root. It doesn't matter if it's plus or negative answer. 8 works. In the next example, we have raised to a third power. Well, that's the same as a cube root. Just to let you know, that is the same as this. Equivalent. So right away, it's already, this radical is already isolated. We're going to go ahead and undo it by raising it to the third power. If I raise this part to the third power, that's going to cancel out. But then I also have to do it to the other side. So I'm left with t minus 3 is equal to 2 times 2 times 2, 8. When I undo this 3 over to the other side by adding it, my resulting answer is 11. So that's how you solve these radicals. Hopefully this helps. You may have to rewind it, ask questions tomorrow in class. Please have a wonderful day, guys.